Welcome all for the video lecturing class on the topic iron carbon diagram or iron carbon equilibrium diagram or iron carbon phase diagram. This iron carbon diagram is very important for us as mechanical engineers because we will be dealing a lot with steel in general, and hence it is important to understand this particular phase diagram. So why we are studying this iron carbon phase diagram? Because steel is by far the most used metal by the industrialized society and probably the only system that is studied in greatest in detail compared to others. And this iron carbon diagram provides a detailed understanding of the solid state reactions in general. So that's why we are just going to study this iron carbon phase diagram. Next we will move on to the cooling curve of a pure iron, or simply called as allotropic transformation in iron. So we know that the iron is a solid state compound. It will be in a liquid state at the temperature of 1539 degrees Celsius. So here it is a liquid state. So at the temperature of 1500 degrees Celsius or above 1539 degrees Celsius, it will be in liquid state. So this the schematic representation of the diagram shows that x-axis represents the time, whereas y-axis represents temperature in degrees Celsius. Okay, so here x-axis we know that the time is in x-axis and the temperature is in y-axis. Okay, the pure iron in the liquid state above 1539 degrees Celsius or 2800 Fahrenheit. When we start cooling the iron to 1400 degrees Celsius, so which is nearly 1539 to 1400 degrees Celsius, we are just cooling to next stage, that is delta stage. This region is called a delta iron region, which is a BCC in crystal. So BCC is nothing but a body centered cubic, which is a crystal structure. Again, when we start cooling the iron from 1400 to 910 degrees Celsius, the delta region undergoes an allotropic transformation, and so where solid state transformation takes place and converts those delta iron region to gamma iron region. So at the temperature of 910 degrees Celsius, this delta iron region is converted into gamma iron region. So here the crystal structure is FCC. So FCC is nothing but a face centered cubic. And then until we start cooling the pure iron from 910 degrees Celsius to 768 degrees Celsius, again this gamma iron region undergoes an allotropic transformation and a solid state transformation takes place and converts those gamma iron region into alpha iron region, which is again BCC in crystal structure. And then alpha iron region is going to be non-magnetic. That is so where the alpha iron region is simply called as a non-magnetic region to begin with, and below this 768 degrees Celsius. Below this 768 degrees Celsius, it regains its magnetic properties, but crystal structure will still be BCC only, that is body centered cubic. Only this not magnetic will become to magnetic, so the magnetic properties will be benefited at this region. So for pure iron, as we have discussed, we have two allotropic changes, that is one from delta iron region to gamma iron region and a gamma iron region to alpha iron region. That is simply we called as a two allotropic transformation takes place in this iron carbon phase diagram. Okay, then we will move to this iron carbon phase. So this is the typical iron carbon phase diagram. So in this the x-axis represents the percentage of carbon and y-axis represents the temperature in degrees Celsius. On the left hand side we are having iron, and in the right hand side we are having FeC, which is cementite. So let us identify some important points. So here the value which is 4.30, here it is, the point is called the eutectic point. Okay, so here the point is called the eutectic point, where liquid is transforming to solids. So this is the region where the liquid is transformed into solids. So this region is said to be eutectic point, and the point which is 0.76. Okay, so here it is the point 0.76. So this region is said to be eutectoid. Okay, so this point is eutectoid point, where austenite transforms into ferrite and cementite. So at the point 0.76, austenite transforms into ferrite and cementite. Okay, so this region which is a delta region. Okay, so here it is a delta region, and this here it is a alpha region, and that is a austenite, and here it is ferrite region. Okay, so these are some of the key important regions, and it is important that we remember this composition and the temperature of these important reactions. Okay, so next we will move on to the percentage and the composition of such variations. This point 0.76 eutectoid point in several books may vary. In some textbooks it can return as a 0.78 or a 0.8. So there may be slight variation, but it is about 0.8. This percentage of carbon is about 0.8, and that is what it is called eutectoid compound. Okay, so the point which we mentioned here in the iron carbon phase diagram, that is 0.76, it may be varied in some textbooks, but normally the value of this eutectoid point is approximately, it is said to be 0.8. Okay, so all of you able to draw this diagram, and you should be able to identify what are the composition and solubility. For instance, if you see this just a minute, so if you see this alpha, ferrite has maximum solubility of 0.022 weight percentage of carbon. Okay, so the region which is here, so this region is nothing but alpha region, that is alpha ion region. So here the solubility of 0.22 weight percentage of carbon. Okay, so the ferrite has maximum solubility. So in this region ferrite has maximum solubility, and the gamma ion has a 2.14 percentage weight solubility of carbon. Okay, so in a gamma region, that is gamma region is nothing but austenite, where 2.14 percentage. Okay, so 2.14 percentage of so here it is 2.14. So this is the region where gamma ion region takes place. Here it is the solubility of carbon is 2.14 percentage. So this solubility limits are something that you should remember, and you should be able to draw this diagram completely at the end of this lecture. So basically there are three important points in this iron carbon diagram. One is a eutectic point, that is here at the value of 4.3, that is a eutectic point, and a 0.76, here it is eutectoid point. Okay, so that is eutectoid point, and so these are the two most important points. And here it is the value of the region is 2.14. So here it is the solubility of carbon is 2.14 percentage, that is in a gamma region. Okay, so these are some of the key composition of iron carbon phase diagram. So the pure ion upon heating experiences a two crystal structure changes, as we have seen early, that is the one from delta ion to gamma ion, and then from gamma ion to alpha ion. The temperature which is above 1538 degrees Celsius, which the solid state is in, which the ion is in liquid state. So that is said to be delta ion region. So We have already seen that two allotropic transformation takes place. That is from delta to gamma and gamma to alpha. So two allotropic transformation takes place in this iron carbon diagram. So one from delta to gamma and gamma to alpha. Okay, so these are the two allotropic transformation, which is very important. At room temperature, the stable form called ferrite or alpha ion has BCC structure, and when you are heating, ferrite changes to FCC austenite or gamma ion. Okay, so at the temperature here it is nearly 600 degrees Celsius. So when we are heating at this region, this alpha region will be transformed into this gamma. Okay, so alpha region is transformed into a gamma region, and again when we are heating, this ferrite changes to FCC, that is a face centered cubic. So austenite remains stable up to 1394 degrees Celsius or approximately 1400 degrees Celsius, at which FCC austenite reverts back to BCC phase. But this BCC, so BCC is nothing but a body centered cubic. Okay, so BCC is nothing but body centered cubic. This BCC phase is also known as a delta ferrite. Okay, so delta ferrite, and which finally melts at 1400 degrees Celsius or 2800 Fahrenheit. Okay, so once while we are keep on the heating this pure ion, at the temperature where it reaches nearly 1400 degrees Celsius, the solid form of ion will transform into liquid state. So these are the some major key points of this iron carbon phase diagram. So with this we have finished our discussion on iron carbon phase diagram, and then reasonable amount of time on understanding the phase diagram of iron carbon system. Hope this video will be very much helpful for the students who are studying the subject like mechanics of materials and the strength of materials. Mostly automobile and mechanical engineering students will able to study these two subjects. So thank you very much, and we will be seen in the next module. Thank you very much.